This video will talk about z-scores. A z-score is used when the distribution can be approximated by a normal curve, or we say that the data is roughly unimodal and symmetric. A z-score is the number of standard deviations above or below a mean. And if you look here at the formula, here's the formula, which is z is equal to x minus mu divided by sigma. Remember that mu is the population mean, and sigma is the population standard deviation. So when we create a z-score, we're transforming the data back to what's known as a standard normal curve. In a standard normal, we say that our x values approach, that's what this means, approaches a normal distribution with a mean of 0 and a standard deviation of 1. Essentially, that means that the center of the curve is at 0, and you have standard deviations of 1, 2, 3 to the right, -1, -2, -3 to the left. What a z-score does is now find the deviation, which is this part of the equation here. That's a deviation, x minus mu, and we divide it by the standard deviation. So it's going to give us a relative position. And z will fall somewhere on the curve. If the deviation is positive, we know it lies above the mean. So these are all positive z-scores over here. And if the deviation is negative, we know it lies below the mean. So these are all negative z-scores here. So here's how we use a z-score. This example says, suppose that a college admissions office needs to compare scores of students who take the SAT with those who take the ACT. Suppose that among the college's applicants who take the SAT, scores have a mean of 896 and a standard deviation of 174. Further, suppose that among the college applicants who take the ACT, scores have a mean of 20.6 and a standard deviation of 5.2. We're going to assume that both these distributions of scores are normal. Suppose two applicants, Erica, who scored a 1080 on her SAT, and Sam, who scored a 26 on her ACT, are competing for scholarship. Who should get the scholarship based on their scores? So because we have two different distributions with two different means and standard deviations, it's harder for us to compare. We know, and we're going to draw a curve here. So let's draw a curve for Erica and for Sam. So for Erica, who took the SAT, her curve looks like this. She has a mean of, or the curve of the SAT scores is 896. And this is Erica's curve. And then we have Sam, who also took a test, which is the ACT, and her mean is a 20.6 on her curve. Now, each applicant scored a certain score. Erica scored a 1080, which sits somewhere out here, and Sam scored a 26, which sits somewhere out here. So we can see that both these people scored above the mean value. Now, relative to each distribution, though, who scored better? Well, in order to do that, the easiest thing we're going to do is be able to find a z-score and put it back on this distribution right here. This will give us our relative position with respect to the mean. So to find Erica's z-score, we do this. Z is equal to her score, which was a 1080, minus her mean score, which is 896, and divide that by the standard deviation, which is 174. So 1080, and that gives us a value of 1.057. Then Sam z-score. Sam has a z-score z equal to 26 minus 20.6 divided by 5.2. And we get a z-score of 1.038. So what that means is if we put these on the same curve where Sam's is at, here's Erica's at 1.05 and Sam's at 1.03, we can see that with respect to the mean, Erica had a higher value, had a higher score. So based off of Z-scores, Erica should get the scholarship.